the first and the third entry must be states. And the first non-terminal starts with P, the destination state. This is fixed, cancel transition. The last non-terminal must be ended with whatever choice you made here. If you chose state number 5 here, you must finish it with state number 5. That's not a free variable. The choice here determines this one. But in between, you can choose any state you want. But the state you start the triplet with must be equal to the state you finish the previous triplet by. So here, when you're doing this triplet, if you chose P, Z1, you don't have a choice here. You have to use P and Z1 from the transition. And then you say state 5. Okay, the next one will start with state 5, Z2 and state 6. Next one will start with state 6, Z3, and make a choice, I don't know. State 6 again. You can use the same. So he will give you a lot of rules. Out of one transition, you get a whole set of rules. Instead of writing in this form, because the algorithm was expressed in terms of delta, it uses the matrix notation, the function notation. Let's rewrite it. So what's the PTA? Let's call this Q0. Let's call this Q1. So the first transition. If you are in Q0, and you see what on the tape? You see A on the tape. And you see what on the stack? It doesn't matter, it could be anything. If you see E on the stack, replace E by what? A, and go to what state? Q0. You stay in the same state. So this is the way to represent this arc, using the delta notation. Okay, and then we have this one. If you are in Q0, and you see what on the tape? Don't use the tape. Okay? And you see what on the stack? It doesn't matter what's on the stack. Okay? You stay, no, you go to Q1 and you replace E on the stack by E. So I have E here, replace E by E. And it only has 3 transitions, the third one. If you are in Q1 and you see B on the tape, and you have A on the stack, stay in Q1 and replace A by E. Okay, that's the PDA. All right, step 1. You take the PDA, you got to convert it to a simple one. Okay. So what bothers me here? Let's check both conditions. Okay. What's this one? The second condition? The second condition says what? If you have a pushing transition, regardless of what's on the top of the stack, if you have E replaced by X, you got to add some transitions. Right? If you push X, no matter what's on top, push it on top of every stack symbol. Replace every stack symbol by XA. So do I have any pushing transitions here where I replace E by something? This one, but also this one. Replace E by something, regardless of what it's E. Okay. All right, so I got to add some transitions. So what do I need to add? Let's fix this one. What is the stack symbols here? A. Q0. A. Okay. What if you had A on top of the stack? Q0. AA. I'm pushing A on top of it. That's it. This is fixed. Now this one, I need to add a transition. What if A goes on toward the stack? A. You leave it alone. This is replace E by E. No matter which one goes, the stack, leave it alone, replace it by itself. So I did step one. It's simple. Now I'm ready to produce the grammar. All I have to do is look at that algorithm and follow. I don't have to use any brain. You know. At this point, I'm a program. I'm an algorithm. Okay. The algorithm says now, here is your grammar. Let's start with case 2. This is the easy case. For every transition of the form in case 2, you can produce a rule. Okay? Now, we lost the projection of the algorithm. Where is it? You have the algorithm there? Wait a minute. I am ready to produce the grammar. In the algorithm, step 2 says, if you have such a transition, a popping transition, you're replacing Z on the stack by E. Z is an individual stack symbol or the empty string. Okay? Then the grammar rule looks like this. Triplet goes to tape. Okay? And what's the triplet? State, stack symbol, destination state. That's case 2, if you look at the algorithm. Okay? So let's apply that. Okay, which transitions does this apply to? These are the easy cases. Okay, so I'm looking for transitions that have E in this position. I'm popping. This guy and this guy. So for these two cases, what is the grammar rule? Okay, for that case. Triplet, non-terminal, right, goes to what? To stack, to tape. What's the tape? E. The content of the tape is E. Okay, what's the triplet? Starting state, Q0. Stack symbol, what's the stack symbol you're replacing? E. Destination, Q1. This is the grammar rule for that transition. Then this one, this is case 2 also. What's the grammar rule? Starting state, Q1. Stack symbol, A. Destination state, Q1. Goes to what? B. What's on the tape? B. Okay? So I'm done with case 2s. What does case 1 say? Well, if you have a transition that looks like if you are in state P and you see something on the tape, and you have Z on the stack. Again, this is a simple PDA. You can only have one single symbol there that you're replacing because you converted it into Z. So if the destination is Q, and you replace Z on the stack by Z1, Z2 by sequence, then what are the grammar rules? We'll have a whole set of grammar rules, a lot of rules. The rules will fit into this template. So that step gives you a template to produce all the rules. Okay, what's the template? Okay, the rules, each context-free grammar, it will be non-terminal, triplet, okay, goes to state, tape content, alpha, whatever is in here, followed by a number of non-terminals. How many? One for each stack symbol that you're pushing. Okay? So one for Z1, last one for Zn. Right? Now, here, what do you have here? Well, here you have the stack symbol that you are replacing, Z. I will go here. What's the state here? The starting state. P. What's the first state of that sequence of non-terminals? The destination state. Am I correct there? Check it out. Right? Do you start at, okay? So you start at Q. So these positions are filled. The rest, you have to fill in with all possible combinations. Okay? But the combinations you fill in there have to satisfy some constraints. So here you can put any possible state. But once you made the choice here, once you put a state here, let's call it S, that last non-terminal must terminate with that state. So whatever choice you made here, you have to make the same choice here. So S is a variable. And then these states in between, you can choose any possible combination, but whatever you chose here, it has to be equal to the last choice of state here must be equal to the first choice of the next one. Last equals first. Okay? So you have to produce all possible combinations that satisfy these constraints. So two non-terminals, two stack sequences. Okay, so what are the grammar rules produced by this? Let's try the templates, and then we'll produce all of them. Let me move this, I ran out of room, so let me move this somewhere, okay? I'm going to keep all my rules over here. My answers will be here. Okay, I got one rule so far. Right? And actually, I don't need these guys either. I used them. I'm left with these transitions. Take the first one. Okay. You will get grammar rules that look like what? Starting state, Q0. What? Stack symbol, A. The stack symbol you're replacing. Variable goes to tape, A. How many non-terminals? Z1, Z2, two of them. A, A. Right? Here you should have the destination state, Q0. Okay, that's the template. Now, how many rules can I produce using this template? All right, here. Well, how many states I have here? Q0, Q1, two states only. So I can put Q0 here, or I can put Q1. Let's start with Q0. Or I can put Q1. Right? In that position. Okay, once I put Q0 here, what are the rules I'm getting? Whatever state choice you made here for state, you must terminate the string with that choice. So this has to be 0, Q0. So that's a sample template. Now I got to fill this out. Whatever choice you made here, you have to make it here. And there are two choices. So I can put Q0, Q0, or Q1, Q1. So out of this, I get two choices, two rules. can put Q0, Q0, finish must be start, or Q1, Q1. Those are the two rules I got by putting Q0 in here. But now I can put Q1, which means I'll get once I put Q1 in that slot, I got to put Q1 in that slot. Okay. Now one choice left. I can fill it with Q0s or Q1s. So how many rules? Let's collect these rules. I got two rules here. I'm going to copy them. And I'll get two rules here, one for Q0 and one for Q1. I'll take it, put Q1 in this position. Okay. So out of this transition, I get four rules. So we don't need that. Okay, now this one. Do you follow? Well, let's do this one. Z1, Z2, Zn. Z1, you only have one stack symbol here. So the grammar rules will look like state, stack, choice. So what is the template for that? Starting state, Q0. Stack, symbol. Right? E. Choice goes to tape. What do you have on the tape? What do I have on the tape? A. Followed by one stack symbol for Z1, for A. Destination state is Q0, so it will start with Q0. That's the template for that rule. So how many variables you have? This one. But whatever variable you put here, you got to put it there. The last no terminal must terminate with that variable, with that choice. So I get two rules. Q0, Q0, Q1, Q1. Okay, so that's what I can start. This. Now, one transition left. Z1, only one stack symbol. It will be easy like that because I only have two states. Right. What's the template? Starting state, Q0. Stack symbol, what? A. variable goes tape. What's the tape? E. You're not using the tape in this one. So I don't even need to write E concatenate. Destination state, Q1. Stack symbol, Z1, Z1, A. Variable. So, two choices, two rules. Q0A, Q1A, Q0A, Q1A. So I can either fill it with Q0s or Q1s. You got the grammar. Okay. Now, let's check if this grammar actually recognizes the language A and B. Did the algorithm work? We did not prove the algorithm, but let's check if what we got is correct. It's too difficult as a human to look at triplets. So let's rename them as ABC symbols, not terminals like uppercase. I forgot to tell you, in that algorithm, it mentions who is the starting symbol in the grammar, right? If you look at the algorithm, it says the starting symbol will be the starting state of the PDA, okay, which is in this case is Q0, followed by the either Z0 if you use the book notations, that special symbol that indicates end of the stack, or E in our case, followed by the final state, which in this case is Q1. That's the starting symbol. Okay? Now, what if the PDA has many final states? Well, you got to reduce it to one final state by putting E arc, one final state. Make all the final states go to 1 by E/EE and make them non-final. It's the same PDA has one final state. So I can always think of my PDAs as having one final state. So the starting symbol is this triplet, right? The algorithm says. So now let's make it look more pretty. Okay, let's find 0E1 over here. Where is it? This one? Hey, let's take one by one, otherwise we'll get lost. Take the first one. 0A0. Let's call this like an A. I'll put this so when I hit it again, I know what symbol I used. Then I'll erase it on that. Okay, 0A0. Let's call it A. Goes to what? 1A0. Let's call that B. Okay, I did this one. 0A1. Let's call that C. Goes to 1A1. Let's call that D. Zero E0. I have not used that yet, right? So let's call that E. Goes to A. 0A0. 0A0, I already used it, I called it A. Right? So this will. Okay, 0E1. E1. Oh, that's the starting state, right? 0, E1. Let's call that S. Goes to A. 0, A1. Yeah, I used it already. I called it C. Okay, 0, E1. Oh, that's the starting state. Goes to E. So I'll just put it goes to this or E. One A1. I use it. I call it D. So D goes to B. 0, A0. Oh, that's A. Goes to, so instead of another rule, I say or. A goes to A. 0, A0. A. 0, A0. Right? A. Right? Okay. Oh, another 0, A0. 0, A0. That's still A. Goes to A. 0, A1. That's a C. 1, A0. B.